This video is for TCAP Check number 7. For number 1, it says Billy is training for a long-distance running event. During one training session, he records the miles run after every 5 minutes. He notices the table shows a linear relationship. The rate of change for the table is behind the rate of change for the table. We want to set up a fraction as the change in y over the change in x. Remember, x is always the first column, y is always the second column. So as we're looking to see changing by, we can see on the side that we're adding 5 each time. 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20, 25 is 25, and 25 plus is 30. On the y column, we're going from 0.625 to 1.25, which is going up 0.625. If you add 625 and 625 together, you get 125. 0.625 added to the 1.25 would give you the 1.875. 1.875 plus the 0.625 again would give you the 2.5. 2.5 plus 0.625 would give you the 3.125. And 3.125 plus 0.625 would give you the 375. Now when it comes to set up our fraction, we put the y value, the 0.625, on top, and the x value 5 on the bottom. And then we can simplify by dividing. 0.625 divided by 5 is going to give us an answer of 0.125. For number 2, it says select each linear function that has a rate of change greater than 1. So in slope-intercept form, y equals mx plus b. The m is the section that is the rate of change. So we're looking at the m sections because we want a rate of change greater than 1. So in the first section, m is 3 over 2. If you were to convert that to a decimal, 3 over 2 is 1.5. 1.5 is greater than 1, so that is a correct answer. For the second choice, your rate of change is 1/2. 1/2 is less than 1, so we're not going to choose that one. For number 3, your rate of change is -4. -4 is less than 1, so we're not going to choose that answer. And for the last one, our rate of change is 3, and 3 is greater than 1, so that is also a correct answer. Number 3, is the square root of 7 rational or irrational? So the square root of 7 is one of the problems that we cannot solve because there is no number times itself that gives us 7. 7 is between the square root of 4, which is 2 times 2, and between the square root of 9, which is 3 times 3. So because we cannot solve this problem evenly, it is irrational. Number 4, which point would be on the line y equals 3x plus 5? So when you have these problems, you can look at your equation, in this case y equals 3x plus 5, and compare it to the equation in slope-intercept form y equals mx plus b. Our m, our rate of change, is 3, and our initial value, our starting point, is 5. Now it's important to remember that on our initial value, when you are on a graph, the initial value is your starting point. And your starting point is always on the y-axis. And so this line would start at 5 with our initial value. And then it would go up 3 and over 1, following our pattern to make our line across the graph. So 5, which is our y-intercept, is the point on the graph. 0, 5 is our y-intercept. Rawl recorded the height in inches and weight in pounds of each of his soccer team members. Then he graphed the data in a scatter plot shown. Select all true statements about the scatter plot of the data. So looking at this scatter plot, the first section says the data have a linear association. This graph is linear because we can draw a straight line relatively through the entire set of data points. The second statement says the data has a negative association. This is not true because our points are going in an upward trend, so we will not choose number 2. Number 3, there are no obvious outliers. That is true. Most of the points are clustered around the same area. No points are completely by themselves. Number 4, the data are clustered about the height of 55 inches. 55 inches would be about right here. That is not where the main cluster is located. The main cluster is located here at about 60 inches, so we're not going to choose number 4. And then number 5, as height increases, so does weight. That is also true because as the children get taller, they typically have more weight. The smallest child is 50 inches with a weight of 110. The tallest child is 70 inches with a weight of 140. So as they get taller, they weigh more.